Hi, my name is Pakorn from the Institute of Oceanography, National Taiwan University. This is my climate change final project, and the title is Trends in Precipitation and Temperature of the Andaman Sea and the Lower Gulf of Thailand. Thailand is a country in Southeast Asia located at the center of the Indo-Chinese Peninsula. Interestingly, Thailand is one of the countries that bordering on two oceans, which are the Andaman Sea on the west coast and the Gulf of Thailand on the east coast. Moreover, as you can see here in the red highlighted frame, there is an effective barrier between Thailand and Myanmar in northern and central regions, and the southern section of this mountain range runs along the Kra Isthmus to the Malay Peninsula. The Thailand's climate is influenced by two monsoon winds. The first one is the southwest monsoon, which lasts from mid-May to September. This summer monsoon brings wet air masses from the Indian Ocean to Thailand, causing a wet season over Thailand. And the second one is the northeast monsoon. This monsoon brings drier, cooler air from China, causing a dry season from November to mid-March. And recently, Thailand faces more consequences of climate change, including flood, drought, and severe typhoons, as well as condition of rising temperature. This is my materials and methods. This is my study sites. The data were obtained from 14 weather observing stations in southern Thailand, of which 7 of them are located in the Andaman Sea side, as you can see here in the blue circle, and the other 7 are located in the lower Gulf of Thailand side, as you can see here in the green circle. As I mentioned earlier, there is a mountain range run along from the north to southern Thailand. I just want to see whether this barrier have an effect on the either side of the ocean in terms of temperature or precipitation or not. Now I'm going to talk about the data set. An average temperature and precipitation from 2008 to 2020 were obtained from Thai Meteorological Department. However, there's some missing data in 2015 in every single station, and the Nino 3.4 index from where the data were obtained from Climate Data Guide. And for the data analysis, the Pearson correlation were performed to observe the relationship between temperature, precipitation, and the Nino 3.4 index. And the Rainfall Anomaly Index, or RAI, were performed to classify the positive and negative severity in the rainfall anomalies. I'm not going to explain this equation because I have a time limit of 5 minutes, but the point here is that if the value is above 4, it represents the extreme humid weather, and if the value is below -4, it represents the extremely dry weather. Here comes to the result. This is the trends of precipitation and temperature in the Andaman Sea. As you can see here, the value of the correlation is pretty low. This means that there is no relationship between the two factors. And in the most station, the amount of precipitation and the average temperature are quite similar, except at Ranong Station. As you can see here in the figure, the precipitation in Ranong Station quite higher than other station. This might be because of the location of their station. This is the location of the wrong station, quite remotely from the rest of the station. This might be the reason why we observe a higher amount of precipitation in Ranong. And this is the result of the lower Gulf of Thailand. And this is the correlation values. As you can see here, the values are also quite low to weak correlation. But the trends of precipitation and temperature are quite the same in most of the stations, except for the Patalong in 2012. There was a big rain that causing flood in 2012. This slide, I want to show you the variation between precipitation and temperature in both sides of Thailand. As you can see here in the lower part figures, the precipitation in the Andaman Sea slightly higher than the Gulf of Thailand, and some station has a low variation in terms of temperature and precipitation. For example, in Krabi, in the yellow dots, they are clustered together, while the other has like a scattered pattern, which means like the variation are quite high. And the highest temperature was observed at the Phuket airport in 2017, and the highest precipitation was recorded in Pakorn. Now I'm going to talk about the Nino 3.4 index relationship with the precipitation and temperature. As you can see here, the figure on the right corner above, there's the highest peak of El Nino in 2015 and 16, but because we don't have the data from those years, so we cannot really compare to that peak. However, we can see in the past 5-year trends, there is an increasing temperature at each year. This is what we can confirm that. I think I'm running out of time, so I'm going to go through the last two slides quite quickly. As I mentioned earlier, the RAI index can be used to classify the extreme weather if the value is higher than 4 or below -4. As you can see here, at the Andaman Sea, there is only few stations that reach 4. It means that only few extreme weather happened in the past. Comparing to the Andaman Sea, the lower Gulf of Thailand had more point that reached 4, which means there was more extreme weather happened in the past, especially in Hat Yai and the Patalong in 2012. In summary, Thailand's climate is influenced by two monsoon winds. There is no relationship between precipitation, temperature, and Nino 3.4 from this study. And according to the data from the past 5 years, the temperature increasing every year. And the RAI index told us that there was extremely weather happened in the past. And the variation between precipitation and temperature are vary between their sites. Before I finish my presentation, I just want to say that climate change is real and it's really happening. And thank you for watching my climate change final project.